Hi everyone, my name is Zaki Ahmed and I founded Pulsiv back in 2013. Pulsiv started off based on my background in communication engineering. So I started off as a commie focused on extracting more power from solar panels. In the course of doing this, I invented a lot of new circuit configurations, some which have applications in the opposite direction. So instead of going from a solar panel into the grid, extracting power from the grid, pushing it into loads that look like solar panels, typically things like battery chargers. So what I'm presenting today is one of the technologies which converts AC to DC, which we call Osmium, which has a lot of very interesting, unique selling points, which I will go through in a bit more detail. The technology itself is basically packaged within a very small microcontroller, which is shown over here, and there is a development system that you can use to evaluate the technology. So Osmium is a microcontroller-based technology that is used to replace the Boost EFC, the Boost part of a Boost PFC power supply. I will go through some of the key features over here, but as they say, a picture says 1,000 words. This, in a nutshell, is what Osmium is. So Osmium is a microcontroller that controls the charging current into a storage capacitor. The storage capacitor is effectively used as a valley fill PFC as a valley fill PFC, and by regulating the voltage on the capacitor as well as the charging current, it can be shown mathematically that you can get up to 96% power factor, and we have indeed measured over 95% power factor in a real system. So the advantage of doing power factor correction in this manner is really in the efficiency profile. If you have a Boost PFC and you design your Boost inductor for, let's say, 100 watts, when you run the Boost inductor at 5 watts, it is extremely inefficient, just because of the losses in the magnetics. However, with a capacitor, this is not the case. A capacitor is very efficient at low power as well as the power that you've designed it for. And this is what leads to one of the key unique features of the Osmium technology, which is the flat efficiency profile. So this graph over here is the measured efficiency with the level 6 requirements shown just as a reference. And what you can see is the Osmium efficiency is very high, and it stays high all the way down to very low power levels. This little box over here is expanded over here just to show you that even down to like 2 watts, it is still a very, very efficient power supply. We took the Osmium technology because it's obviously just the front end, and coupled it with a follow-on flyback converter to produce an end-to-end power supply. We partnered with a company called Salom, who produce power supplies for a living, and this is measured data from them, and it shows the efficiency of a Pulsiv solution. So the green line is the Pulsiv with a flyback DC to DC converter, and as you can see, the flat efficiency profile is maintained from 100% all the way down to 10% right across the entire power range. When you compare this with a resonant converter or indeed a Boost PFC followed on with a flyback, you see the typical efficiency curves which drop off at the lower power end. And going forwards, the efficiency at the lower power end is key to delivering high efficiencies in a typical use case. Normally, things like laptop power supplies are always plugged in. It's a very bad habit, but everyone does it. Most people connect up a battery charging power supply, leave it plugged into their laptop, and carry on using their laptop even though it's fully charged. And that provides a typical use case of how a power supply is actually used. So although you might have a 65 watt or 100 watt power supply, it will only run at full power when your battery is extremely low. Once your battery is 80% or 90% charged, the power that is being drawn by the power supply is much lower than the rated power, and you will spend most of the time at the lower power end, where normally you would have poor efficiencies with conventional power supplies. With a Pulsiv enabled power supply, this is not the case, and you can have significantly higher efficiencies, especially in this lower power mode. So in a typical use case, even though the peak efficiency of a resonant converter is higher, in a typical use case, a Pulsiv enabled power supply will have a much better overall efficiency comparatively. There is a lot of additional information on our website regarding this. So the Pulsiv Osmium microcontroller does a lot more than just power factor correction. There are active bridge control signals, there is grid indication, as well as other elements as shown over here. If you need additional information, there's a lot of resource on our website, www.pulsiv.co.uk. You can contact us, but there are also reference designs and design guides available on the website that you can use to investigate the technology and use it in your own designs.